Hey guys, and welcome to DoAfCo.com. So this is the first lecture of our Embedded C series, and in this I'm going to talk about how to read a data sheet and how to read pinouts and how to understand the ABR libc manual. And then I'll talk about how to program your very first program, that is the hello world to Embedded C, and we call it blinking LED. So let's get started. So here, first of all, you need to download the datasheet, and the board that we are going to use is our Arduino Uno board. So if you must be thinking that we are talking about Embedded C and why we are using Arduino board. So most of us have used Arduino board with the help of Arduino libraries that is already present, and various examples that are present in Arduino IDE. So if you want to program your Arduino board using Embedded C, then you need to know what is the controller that is there in the Arduino board. So Arduino board has Atmega 328P controller in it. So for that you need to download the datasheet of Atmega 328P. So for that all you need to do is to write on Google Atmega 328P datasheet as I've written. So after that you will get the PDF from the microchip.com, and this is the PDF. So after that there is one platform called Tinkercad. If you don't have the board, since I need to record the video, so I've used this platform, and you can also use the real hardware if you want to. So this is Tinkercad. Here you can create small circuits, and all the components related to the circuits are already present, and you can even get circuits of basic Arduino circuits from the starters. So I've created this small program of for blinking LED circuit. So after that what you need is to know how to read the datasheet. So I've already written this blog about it, but all you need to do is to read it fully, or you can even watch this video and understand, but along with that you really need to read this blog to understand more about it. So in datasheet, for the very first chapter is about the feature of our microcontroller. So Atmega 328P is a AVR architecture 8-bit microcontroller. So it's advanced RISC architecture base. So there is a difference between RISC and CISC architecture. I will tell you about RISC and CISC architecture in some other lecture. So after this there are peripherals which are present. So our board has two 8-bit timers and one 16-bit timer. So I've already written a blog about timers, and I'll make a video about it very soon. So if you want to know about timers, then you can read that blog. I'll put the link in the comment section. So after this comes, what we need to do is we need to program the input outputs. So for that you need to program the GPIO, and for that you need to go to the chapter called wait a minute, let me find that chapter. So there is this chapter called IO port. So this chapter will tell you how to program input output. So as we are programming LED, so LED is the output. Since you see the LED blinking and you can see it from your eyes, so it's an output, and like you use buttons, so buttons are like input. So here we have LED. So how we need to program? So basically there are three registers in IO, that is, as you can see there are three data registers, that is port register, DDR register, and pin register. So what are their uses? You can read this whole so as to get the understanding of basic electronics behind it. All I will tell you is what are the main points that you need to read. So how you need to configure the pin is written here. So each port consists of basically three register bits as it is written, that is DDR, port, and pin. So what does DDR do? So DDR bit is data direction bit. So if you write logic 1 to DDR, that means that particular pin is configured as output. So if you write logic 1 to DDR somewhere, then that particular pin will give the output. So since in our circuit I've put the LED in digital pin 13, so if I will write the DDR of digital pin 13 as 1, then this would turn into output. So that's what we wanted. So after this, if you write logic 1 to the port, then pin is then the pin is turned on, and if you write logic 0, then the pin is turned off, that is high. And so here it is written. If you write logic 1 to the port pin, then pin is configured as output and the port pin is driven high, and if you write logic 0, it is driven low. So if you want to blink the LED, so when you turn on the LED, then it is logic 1, that is high, so the LED is on. And if you write logic 0 to it, then LED is off. So all you need to do is to set these two bits, that is DDR bit and port bit. So after that we need to know the pin diagram. So this is Atmega 3280p pin diagram. You can also get it by writing on Google Atmega 3280p pin diagram. So here you can see digital pin 13 is PB5, that is where there are various ports. So this is port C, this is port B, and this is port D. So our digital pin 13 is the fifth pin of port B. So all you need to do is to write the code. First of all, you need to include some header files, that is AVR-IO and delay.h. if you want to use the delay, that is already created in the library. So for knowing these header files, you need to go to AVR libc reference manual module. So here you will find all the header files that you can use and are available by AVR libc library. So here we are using AVR-IO.h, and so you can read about it. So you can directly write on Google AVR libc reference manual and you will get it. So after this we need to write some macros and you can directly do it. So these are the macros of setting a particular bit. So about setting a bit or resetting a bit, I'll make a separate video, that is bitwise operators. So you need to go through that video, since I've not created it yet, so you can learn it from my blog, that is I've already written about bitwise operator. So you can go to the C section and you can read about them. So what I done in this macro is we took the port number and then particular bit, that like PB5. So B is the port and 5 is the bit number that we need to change. So after that what we need to do is to set that particular bit, and for that you need to do ORing and left shift, and for clearing a bit you need to do ending, negation and left shift. And so here after this comes the next part, that is the basic use without any macros. So if you want to do it, then all you need to do is to set the fifth bit of DDR bin. So if you want to understand it visually, then here I've created this diagram. So take this as your port B. So these are the various bits that are present in this whole port. So if you'll see here, then you can see there is PB0, PB1, 2, 3, 4, 5, 6 till 7. So these are all bits. So what you need to do, you need to set only this bit, that is PB5. So if you want to do this, all you need to do is to first set this bit as output, that is to set the PB5th bit of DDR as 1. So for that what we did is we have left shifted this DDR to PB5. So if you know the left shift, then you will understand it, that it's like earlier there was all 0, and then what we did, we have shifted 1, that is 1 from PB0 to PB5th. So now here is 1, and then we have done ORing with the earlier values, that is whole 0. So if you do ORing, so earlier it was 0 and now it's 1, and if you do ORing, since you know the result of OR would be 1, so then this bit would be set to 1. So after this bit would set to 1. That was I've written in the macros. Either you can use it this way, or you can directly write set and then name of DDRB and then PB5. You can use it this way also. So after this, all we need to do is to make this high. So we have done again, put 1 in the port PV5th bit. So now it's high, then we give the delay of half second, and then again we have cleared it. So for clearing, what we did, we negate that value. So that means if the value of that particular bit, that is PB5 was 1, we have negated it and made it 0, and now this whole is 1 and only PB5th bit is 0. So now if we AND with earlier values, then since all the values would be different and there is no 1-1 combination present, so all the value will turn to 0. So this whole port will become 0. So this would make PB5 as low. So the LED will turn off, then there is delay. So if we'll start the simulation, then you can see. Okay, so this was the comment, and if you will start the simulation, then you can see the LED is blinking. So since it was not in while run, so it blinked for only one time. So if you want to blink your LED for a long time, all you need to do is to put it in a while run. So after this, your LED will keep on blinking. Okay, so this is all for this lecture. Stay tuned to my blog and my YouTube channel to learn more about embedded. Till then, please like, share and subscribe. Thank you.